Thanks, Ron. Thanks for that. Definitely, as Ron said, and as all of us see in our day-to-day activities, security is one of the most critical things, especially as we talk about it in cloud, right? And more important for us is our CEO Andy Jassy always says, security is job zero. So it is the most important thing for us. And my name is Mahesh Guram, and I have my email address out there. It is vengurra@amazon.com. Feel free to email me about any AWS service, right? So more than happy to help you with your cloud journey, irrespective it is on security or anything else. So we have about 30 minutes. I'll try to cover up everything that I have here. So we will talk about three important concepts of security, right? So the first one, we will talk about identity and access management. Then we will dive a bit deep into key management service. It is called AWS KMS. And then we will try to cover something with VPC. Again, it is an optional topic based on the time we will see whether we can go there. Again, the reason it is kind of optional is we are going into a serverless environment. So there is always a debate about do I need VPCs or not. So these are the three things I will cover today, and by the end of it, you will have some foundational knowledge about how security works in AWS, how we look at security. The first one we will talk about cloud infrastructure. That is where we will talk about IAM, about securing your data in AWS, that is KMS, and finally your network, that is VPC. Again, this is a 100 200 level talk. So if you want more detailed information, let Ron know. More than happy to assist you guys in the next one. So what is IAM? So IAM for us is two components, right? One is your authentication, where you say who you are, and the second one is authorization. Do you have the rights to what you say you want to do, right? And most of everything that we have in AWS IAM pretty much can be done through APIs. Why is it a big thing? Because every most of the services on API on AWS are done through APIs, which gives a lot more control to the individual programmers to either launch new resources or stop existing running resources and do something different, right? So, and how do you authorize these APIs is again very important thing. We will talk a bit about that. And the first one is when you log in into any AWS account, the first thing you give you is your username password. So we categorize the users into two different components. One are human users who actually have a username password. The second one are more of service users, which I'll talk about. So in this case, we have a human user. He will be authenticated using a username and a password. And these are long-term credentials in the sense, once you set your username password, it is valid at least for a 30-day or a 60-day, which again is a configurable thing. And then you also can tie up your AWS IAM, the credentials. If you already have an existing one, like a corporate directory, like a Active Directory, you can also through one of the AWS services called Cognito, tie it up with Amazon, Google, or Facebook kind of credentials. You can do all of that. So how it works is basically when you have when you tie it up to one of your corporate identity, once you're authenticated through the corporate identity, you get a IAM role, and the IAM role will define what are the activities you can do. I talked about IAM role here, which is more like a role where it is a developer's role where they can do XYZ, and then users are added to those roles individually. So the other non-human callers, the service calls, basically, let's say you have an Amazon EC2 instance, a Lambda function, and now the Lambda function wants to talk to an S3 bucket or wants to interact with a file on an S3 bucket. There are a lot of how does that happen? It all happens through roles, and roles are temporary credentials that are offered, right? So, for example, when you upload a file onto Amazon S3 bucket, you can trigger a Lambda which will say, "Hey, this file is a PDF file." Right? Even to determine that, the Lambda function needs to have access to read what is coming in that S3 bucket, and all of that happens to the AWS role. And what the AWS role does behind it is it provides a temporary credentials and temporary authorizations, which are extremely short-lived, and those credentials are used to access those files. And if you have multiple files uploaded, you get multiple credentials, and you don't have to worry about where these credentials are maintained. All of that are handled through APIs behind your scene, right? And how do you create a role? Again, as I said, I'm trying to be more practical here. So once you go into IAM and say, I want to create a role, the first one is what you see a role. This is where you create a role for a non-human process. And as you can see, you have EC2, you have the services listed down, which service should access which service. The other one is role across accounts. So for we have a couple of examples later. We will talk about it, but this is a scenario where you have two different accounts. You want data in one account to be accessed by data in another account, or you want user in one account to do something in another account. You can do that as well, and that is what we call a role for cross account access. And the last two are federated, right? So SAML integration is where I was talking about integrating it with one of your existing ADs, or where you can actually do OpenID through Cognito. As I said, you can integrate it with the Googles and Facebooks of the world. So the roles, there are two types of roles. One of them are called managed roles, where we as AWS define most of these roles, right? There are, I think, like at least 1,000 of them. So based on this managed roles are maintained by AWS. So as we release new and new features on each of these service, we keep updating these managed roles. You cannot change an existing managed role, but if you want something more specific, you can create a role by yourself, or you can create a policy by yourself. So sorry. So in this case, this administrative access policy is basically the policy where you can do anything on the entire AWS account. So this is a policy level access. So once you have a policy, you assign a policy to a role, and you assign users to a role, and that's how all of that works together. So these are managed policies, as I said. That's how it works. So as you can see, you have Alexa for business device setup. Again, that's a policy that is managed. So how do you know? Like if you see this small icon towards your left, that is a managed policy. When you do a custom one, you get a different icon there, which will tell you whether it's a managed or a user policy. So how, like one of the biggest questions I normally get is, that's fine, but in an enterprise, I have multiple accounts, one for development, one for test, one for a pre-prod, one for prod kind of environment, and I want developers to have access to development and test. I want my production support to have access to pre-prod and prod, and I want my shared services or security to have access to everything in across environments. How do we handle this, right? So as I said, you can do that using cross-account roles. So you can have you can have your role such a way that people can access multiple accounts, and they can do whatever they need based on whatever they are authorized to do. So in this case, as you can see, your left users can have access to the first two, whereas your right users can have access to the last two accounts. So how do you do that? It's basically, again, I didn't dive deep into these policies, but basically what this JSON here looks like is it talks about your effect, whether you allow or deny. So by default, everything is denied. So if you want to allow explicit access, you need to specify. And what is the action? You want to say S3 get object. So you are allowing a certain action on this S3 get object. And what is that resource? So if it looks pretty complicated, it is basically a ARN, what it is called Amazon resource name. So everything in AWS will have an ARN, and that is what the resource is. So now in this case, we have two different individual accounts 111, starting with 111, and the other account starting with 444. So the idea is you want the IAM in your account to have access to the S3 bucket on your second account. And how do we do that? By default, you will not have access, because you're not by default you cannot cross the boundaries are only limited to your account. So unless your second account has allowed you explicit access. So in this case, if you look, the principle right there tells that whenever the ARN is coming from, whenever the request is coming from my first user, which is the account 1111, and the user is root, then let them give access to this bucket, right? So unless your second account explicitly allows you this access, you will not be able to access that bucket, right? So the reason we want to do that is we want to make sure everyone, like your 444 account in this case, has complete authorization on who can access and who cannot access that bucket. So this is actually what we call resource-based policy. So the AWS resources have policies that are sitting around them. where they can allow access from the third for multiple other accounts. So some of the AWS resources do not have resource-based policies. Like in this case, we are talking about a DynamoDB table. So if you don't know what DynamoDB is, it is our implementation of NoSQL. So that is, so in this case, let's say I have data, I have a user in account 111. He wants to have an access to the DynamoDB table in account 2, which has 444. So what do we do in this case is, as you can see in this case, we are saying the same way, the effect, action, and resource. And then you actually allow also the ARN here, where you say the principal is so. But behind the scene, what happens is we use what we call STS, right? So STS is another service of AWS, where what happens behind the scene is whenever the request goes from your account 111 to account 444, it goes through STS. STS is a service which will actually do all the validation. It has to make sure, hey, it will basically check whether the resource is my table in this case, from account 444, does it have the principal and all of that, and does it have assume role basically means that it is now going to take up a new role in AWS, like very similar to the IAM roles, and that role will be able to, whatever role that is assigned in that case, will be able to do those operations, right? So in this case, they could be able to create new data, just only read the data and do a lot of things. The important thing is STS will actually create temporary username and password that the caller can use, right? So it all happens behind the scene, but it is important that you understand that STS actually creates you temporary credentials that are valid based on whichever service you do for X amount of time, right? So for example, if you do it for S3, it's valid for an hour. I think Dynamo is as well valid for an hour. So those credentials after 1 hour, the credentials are no more valid, but any connections that are existing are still open. So people will be able to look into do certain activities with open connections. But there are options where you can actually kill all the connections when the time expires. So that is what IAM is. So now I will jump into KMS, which is the key management service. So encryption and decryption is a very important thing across AWS, or the data, what we call data at rest and data in transit. So as you have seen, we have multiple services, right? So data moves between service A and service B. So the transit of the data should be encrypted well enough. And also as the data sits in S3, you want to make sure it is all encrypted. We by default do some encryption. So whenever you put a file in S3, it is encrypted by default. And KMS is an additional layer on top of it, where if you want some special encryption that you guys want to do for whatever reasons, for regulatory reasons, or you want to have your own keys, we support that. Again, as I said, it is extremely important, and KMS integrates very well with a lot of our existing services. I will show you how it integrates with S3, but it is very similar with other services as well. So there are two ways in which KMS does encryption for you. The first one is symmetric encryption, and KMS only does symmetric encryption. If people who don't know what symmetric and asymmetric is a quick difference there. Is symmetric is you have a key, you encrypt the data using the key, and then you decrypt the data using the same key, exact same key, right? So you have a key, you say one converts to two, and then you have the same key, two converts back to one. That is symmetric encryption. Whereas asymmetric encryption is you have two different keys. You have a public key and a private key. So you encrypt with the public key and decrypt with the private key, and you can do it the other way as well. So KMS only supports symmetric, and when you have less than 4 KB of bytes, if you have a file less than 4 KB, what we do is you can easily do it using like something like KMS.encrypt. In this case, hello world, it gives you a big valid string, and then you can do KMS.decrypt, and again it gives you back hello world. Very simple, very straightforward API calls, right? And all of these are API calls, so very easy to do. But what if the data is greater than 4 dB, right? Then we do what we call envelope encryption. So this is kind of a two-step encryption process, right? Again, you don't need to really worry about it, because again, it is all taken care by KMS behind the scene. But if you want to really understand it, what basically happens is you generate what you call a data key. So every time, for every individual account, you always have a customer master key from KMS. So using that, you will generate a new data key, and that data key is very similar to whatever we did here, encrypt, decrypt. It will take 4 KB bytes of your entire file and all decrypt all of that. And then what it will do is the encrypted data is stored along with the plain text of the file. Plain text in this case, the plain text in this case, what we mean is the actual data key. You don't need the data key because you exactly know how to decrypt it through the process. I think I have a slide which actually shows that. But the whole idea here is you have the data key and you have the file, right? So you use the data key to encrypt the file, and then you use the encrypted data key to actually decrypt the file. So that is how it works. So it's called envelope encryption. So we will not go in much into that, but this is an S3 console where whenever you upload a file, by default we do AES 256 encryption for you. But if you want to do KMS encryption, what you can do is you can basically select it, and then based on your keys, you can actually select what key you want to, right? So that key, the AES 256 is, as I said, by default, AWS manages that for you. And the KMS key is where you actually create a key for yourself. By default, you get a customer master key, but you can actually have as many keys as you want to do your encryptions and decryptions. So that is what we do with KMS. Again, very extremely important, especially for data when you're at rest, right? So you want to make sure you understand how all of that works. And as I said, it has integration with S3. It actually has a lot of integration with EC2. It has integration with Lambda. It has integrations with, I think, about 40 plus services right now, and it is continuously evolving. So there are a lot of integrations. So if you want to think about how do you do that, it is again very useful thing. And the next speaker is going to talk to you about secrets manager. Again, very useful thing, especially when you want to store your secrets. I'm not going to go there in this. So VPC is VPC in your AWS is kind of your virtual cloud, right? So it is like your data center on the cloud. So once you create a VPC, no one can get into that account and that VPC. And so that is kind of what the VPC are. And VPC has three different subcomponents. We will talk about the first one is your availability zones. The second one is your subnets. The third one is your security groups. And you can apply security at each of these layers. So you always have a region. So for example, we have North Virginia is an AWS region. So when you say you have a region, it is North Virginia. Ohio, we have a region. We have a region in Oregon. We have a region in US West too. And throughout the world, we have about 24 regions. Sorry, 22 regions, and 4 of them are coming up now. So each region, when you look at from an account perspective, it will have multiple availability zones, right? So each region has at least 3 availability zones. So in this case, we are talking about EU West. So you have EU West 1A, 1B, 1C, and then you can create a VPC in your account, which will span across multiple availability zones, right? So the first two are generic in the sense from an AWS infrastructure point, you have a region and multiple availability zones. And then when in your account, you can create this VPC which will sit across. And for people who are wondering what that CIDR notation is, that is a notation of what are the IPs available in this VPC. And within a VPC, you can have what we call subnets. We will talk about the difference between public subnet and a private subnet in a second, but you can have subnets in each individual availability zones. So public subnet uh, is a is a subnet which where the resources in that subnet have a way to get into the internet, right? So we have that access controlled through internet gateway. But any resources, for example, if you launch an EC2 instance in your public subnet, it will be able to go and access the internet. Whereas a private subnet is private in the sense that no one apart from the restricted access path can have access to the resources in your private subnet. So we will a good example here is your network load balancer would be in your public subnet because that is what is publicly facing, and all your users would be hitting this network load balancer. And based on the load, your network load balancer would distribute that among your EC2 instances, or even your RDS databases would sit in your private subnets. So a typical good example again would be something like this, and we are going to talk about what security group is. Security group is basically that sits around each EC2 instance, or you can create a security group which you can use across multiple instances. Basically, it will tell you things like where should the access come from, where is the access allowed from, and by default everything is denied. So unless you explicitly say I need access or I allow access from so and so, it would not, right? So for example, in this case, if you look at it, in your first layer you want the internet to be able to access it, so you're opening 443 port and the source is from anywhere on the internet. You want the data to come in, they should be able to access it. Again, these are inbound rules, as you can see. There are also outbound rules. The same way you can restrict inbound, you can restrict outbound. By default, whenever you open an inbound port, the outbound opens as well. So the second security group in this case is between your network load balancer and your EC2 instance. So if you see, the source only can actually come from the source from your network load balancer. So any request to my EC2 instance should only come from the layer which is above that. In this case, it is my network load balancer. So that is what in this case we are restricting it, and we are restricting it to a port 8443. And finally, very similar to that, we are actually restricting any access to my database layer through EC2 instances only, and through port 3306. In this case, I'm using MySQL, so that is the port I'm restricting it to. So if you really look at it, the control is extremely narrow, in the sense I exactly know what is the IP range or what is the security group I am able to get the access from, and also I'm restricting which ports can access it. So for example, in this case, for an RDS instance, if you are trying to access the same RDS instance from somewhere else or outside the world, you would not be, because you are restricting all of that, and this is in a private subnet. So there are few of these AWS resources which do not sit in the VPCs. So right now we talked about how security groups control access to these VPCs. But what if I have some of these resources which do not sit in these VPCs? How do I do that? Right. So a good example of that is S3, DynamoDB, and a few others which do not sit in your VPC. Then how do I interact with them through my individual sites? Right. So there are ways you can do that. Right. So in this case, for example, you want to interact with CloudWatch, where you actually want to send your data into CloudWatch. What you will do is you will add, there is a range of IP addresses that you can use, and that is all out published out, and you actually can have what we call VPC endpoints, through which you can have interaction between these two. Unfortunately, I think I don't have the slide for that, or do, yeah, so this is how you do it. So we have the VPC endpoint. So what you would do is you would create a VPC endpoint in your private subnet, and you would basically send data into that private subnet. Yeah, you would basically be sending the data into that VPC endpoint through your private subnet, and that data would be able to interact with your CloudWatch. So again, wherever the services do not sit within a VPC, you would try to use VPC endpoints to interact with that. Pretty much that is, and you basically add a security group around that endpoint to make sure how to make sure the path is only in this case you would add the outbound path, right? Because you're sending the data. And one typical use case where you would use that, or is, let's say you have an application which is running and you want to actually send the application logs into CloudWatch. And in CloudWatch, your idea is to get one holistic view of your end-to-end applications. So again, a CloudWatch would be a very good use case of that. And how would you do that? Is you would use VPC endpoints, because CloudWatch does not sit in one of your subnets. I think that's it I have. And yeah, again, there are a lot of videos out there. I know it's a very short talk, 30 minutes. So I try to get some of the key components in here. Again, strongly encourage you to start looking at AWS free tier. We have a lot of learning tutorials out there. Feel free to do that. And again, feel free to also let Ron know if you want any further sessions. More than happy to help you guys out there.